All right, so today we're going to talk about 8-3, quotients of powers. The big idea for this is because of the relationship between multiplication and division, quotients of powers can be themselves written as powers. What I want you to notice is yesterday we did 8 to the 5th times 8 to the 3rd, and as long as these two bases were the same, what did we do with our exponents? Well, what you should be saying right now is we added our exponents. Okay? 5 plus 3 was 8. So 8 to the 5th times 8 to the 3rd gave me 8 to the 8th. Much is with quotient of powers. If I have the same base, b to the m, divided by b to the n, same base, b, I got m and I got n. Well, if I multiply, I add my exponents. So if I divide my bases, what do you think I have to do with my exponents? I have to subtract. Now, what I want you to notice is this is written in the numerator. And that's going to be very important when we get into negative exponents and all that, which we're going to get into tomorrow. So let's get into it. Okay? Here's something kind of similar to what I already talked about. Okay? We're going to do a problem as an example, x to the 10th power divided by x squared. Okay? The long way of doing all this is I have 10 x's up on top, I have 2 x's down on the bottom. Well, this x takes care of this x takes care of this x, which means then I just have 1 on the bottom. How many x's do I have on top? Well, I have 10 of them. 1, 2, 3, 4, 5, 6. Sorry, not 10 of them. I have 8 of them. 1, 2, 3, 4, 5, 6, 7, 8. You add all these exponents up, 1 plus 1 plus 1 plus 1 plus 1, all the way out, gives me x to the 8th power. So yeah, if we share the same base, 10 minus 2 gives me 8. Here's the quotient of powers property. If they share the same base, it's equal to the base to the m minus n power. This is a power, m minus n. Okay? It's raised to the power. So let's look at 1. Simplify each expression. Do these two things share the same base? Yes. Our base in this case is a. What's 7 minus 4? 7 minus 4, you all are going to tell me, is 3. Here in this case, are my bases the same? Yes. What's my exponent on the denominator? The denominator has an exponent of 1. So this is y to the 12 minus 1 power, which is y to the 11th. Over here, m to the 14th divided by m to the 5th. Share the same base, m. 14 minus 5 is 9. D, they share the same base, which is n. 13 minus 13. Well, what's 13 minus 13? N to the 0 power. Well, what's anything to the 0 power? Anything to the 0 power, you should remember, is 1. Okay? Another way you could think of that problem is, what's 3 divided by 3? Well, 3 divided by 3 is 1. So n to the 13th power divided by n to the 13th power, these two things are the same. When they're the same, they come out to be 1. Over here, quiz yourself. Same base? Yes. Z's. 50 minus 10, you all are going to tell me is 40. Great thing about a lot of these problems is you don't need your calculator. We should all be able to subtract numbers. The zero power, as I just showed you, kind of in question 1D from the previous activity. N to the 13th divided by n to the 13th equals 1. Okay? You're subtracting the same number. So it gives you b to the 0 power. Okay? B to the 0 power is 1. That's just going back over the 0 power property. Anything to the 0 power is 1. Let's look at example 1. The gross domestic product, GDP, of a country and the total value of all the goods and services produced in the country, when the GDP is divided by the population of the country, the result is the GDP per person, often called GDP per capita. In 2006, Denmark had a population of about 5.5 million and a GDP of 243.4 billion. What is Denmark's GDP per capita? So what we have to do is we have to take their GDP value divided by their population. Okay? Now, there's two ways you could do this. You could write this in scientific notation, or you could write this as a very, very big number. Okay? Both ways are going to work. If I was you, I would use scientific notation. So, what most of you may need is a little brief description of what scientific notation is. I know we went over it in the first section, but not all of you might have got the gist of it. So, I'm going to write 243.4 billion as a regular number, which is going to be 243, 4, and then billions, these are billions here, they have what would be 9 zeros, but since I got the 4, it's 243 billion, 243.4 billion, so I have a 4 here, and now I need 8 more zeros, okay? 243.4 billion divided by 5.5 million, okay? We all know millions have 6 zeros, so it's 5, 0.5, so it's 5, 6 zeros. This 5 takes the place of the other 0, okay? So, there's my regular number. To put these into scientific notation, remember, you have to have a number in between 1 and 10 times 10 to some power. Now, how do I get this number in between 1 and 10? Well, if I put a decimal point right here, 2.434 is going to be a number in between 1 and 10. So I'm going to write 2.434 times 10 to the, well, there's 3 places, 6 places, 9 places, 10, 11th place. How do I know it's positive? 243.4 billion is a very big number, so this exponent is positive. 5.5 million, okay? The number in between 1 and 10 is going to be 5.5. So it's 5.5 times 10 to the 3 places, 6 places gets me right here. So it's 10 to the 6th. Remember, it's always 10 to some power because only 10 gets it to move to the right or to the left based on if it's a big number or if it's a small number. Now, watch how I break this problem up because it's a lot easier than sitting there and maybe you don't have a calculator or maybe you do. But you can break this up and use your quotient powers property. So the first thing I'm going to do is I'm going to take 2.434 and divide it by 5.5. And you all are going to tell me it is about 0.44 times 10 to the 11th divided by 10 to the 6th. Same base, so I can subtract my exponents, which is 11 minus 6, which is 5. So this is 0.44 times 10 to the 5th, okay? We don't normally write our numbers like this because we want to know what was Denmark's GDP per capita, okay? What was their gross domestic product per person? So I need to move this 5 units to the right. Well, 1, 2 units. So how many more zeros do I need? I need 1, 2, 3. 1, 2, 3. So in Denmark, their gross domestic product per capita was $44,000. Okay? Now, you need to remember this problem because this is going to be on a quiz. Same type of problem. They're going to give you the gross domestic product. They're going to give you a population. You're going to have to take the gross domestic product divided by the population. Very important. Let's look at example 2. It says simplify. 30, 8 to the 3rd, n to the 6th, divided by 5, 8 to the 2nd, n. Now, some people like to separate these so they get the common things together. Some people can just go ahead and do it. I'm going to show you both ways. Okay? I'm going to separate these out. So 30 and 5 are coefficients. So I wrote 30 divided by 5. The A's share the same base. So I can write this as 8 to the 3rd divided by 8 to the 2nd. Notice I have a multiplication symbol in between there. Why? Everything that's side by side means multiplication. So that's why I can write it like this. All I'm doing is breaking everything up. Times my bases are n to the 6th all over n. Now, you can't put n's and a's together. You can only put a's and a's together, n's and n's together, coefficients and coefficients together. Now, this should be a pretty easy problem. What's 30 divided by 5? 6. What's a cubed divided by a to the 2nd? Well, a cubed divided by a to the 2nd, my base is a. 3 minus 2 is 1. Here, bases are the same, so I get n to the 6 minus, and this is a 1, so 6 minus 1 is 5. Now, do we write our problems like that or our solutions like that? No. We write them side by side, so just get rid of the multiplication symbols, and this becomes 6a n to the 5th power. And normally what you want to do is you want to write your variables in alphabetical order, okay, just to keep them straight. Now, if you can go over here and you can look at this and you can say 30 divided by 5 is 6, Fine. Match up your A's or your bases. So my A's 3 minus 2 was 1. And n6 minus 1 is n to the 5th. Okay? Yes, can you do it short and sweet? Some people can. Some people can't. Here's the steps you should follow if you can't do it in your head. Now, what would happen if I gave you something like this? Okay? By looking at this, what you should be saying to yourself is, can I take 12 divided by 4? Yes, it's 3. What happens to my A's in this case? Well, a to the first divided by a to the first, those are just gone to 1, multiplying by 1. What about these B's? Same thing. They're gone. Is there anything to do with c to the 5th? Nothing besides bringing it down. C to the 5th is on top, so I need to write c to the 5th also on top. Okay? Just because it doesn't have nothing to divide it with doesn't mean you just throw it out. It's still part of your solution. These little steps are going to help you to make negative exponents that much more easier. Okay? We will review over these 3 sections and make sure you are ready for negative exponents before we move on. Thank you very much. We'll see you tomorrow.